welcome. Uh, to be completely straight up, today's gonna be a quickie. I mean, we're talking maybe 10, 15, 20 minutes. Let's just knock out data sets and data loaders. I don't really have too much time today, so this is gonna be a rush through. But I wanted to get something done, right? I wanted to just do a little bit. Normally, this would be I would watch some AI engineering videos. I would just research a couple terms. I would uh, kind of in the downtime watch someone make their own AI, right? But I don't want to leave you guys behind, right? Everything that I'm doing here is all that I'm doing, every single aspect of it. So I would hate to, dig into data sets and data loaders and come back tomorrow like, oh yeah, data sets are obviously blah 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 blah, right? So um, let's go ahead and knock this out really quick, and then I'm gonna be out of here. If I'm being completely honest. So yesterday we started working on the actual training.py. Um, we imported Torch, and from Torch we got the utility data loader. We got the data sets and transforms. As we know, data loader is essentially wrapping around data sets for the AI to work with. And transforms is using a resize of 224224, which is going to set it to the height and width of 224. Transforms it to a tensor and then normalizes it based off of the image net that we're going to use. And the mean is essentially the red, green, blue of all the images. This is the intensity of the mean of all the pixels inside of the entire database of the image net. And then this is the standard deviation for each pixel color, RGB, right? So we are naming that object Bumblebee because it is going to be transforming for us. And let's get to the underneath. So we have data sets, training data set, and we have a validation data set. The training data set is what the AI is going to be working with to essentially learn the patterns. And then the validation data set is what the AI will use to check to see if the patterns learned are are viable for untouched data, right? So the validation data set has not been trained on. It'll be fresh pictures that it should be able to parse. Yada yada, train loader, and then this is creating a batch for each of those data sets at a to work with at a time. Um, shoot, because I would really like to go into num workers, batch size, shuffle. What is all that exactly doing? I am really running out of time, so let's go ahead and knock this out, and then tomorrow we'll come back and actually look over it. All right. So let's start off with the training data set. So we'll call this um, training data equals. What does that equal for us? Data sets, right? Because we're grabbing a data sets dot image order. It was, I believe. Yep. And then we have our root equals no quote since we're using variable, and then this is going to be the training dir as we set up here to be back a directory and inside of this train data which has cornerback receiver. Right? So from there you are then applying the transform of what, right? Transform of this object, which is going to be Bumblebee for us. So then we say transform equals Bumblebee. Okay. Bum, bumble, bumble. There. And then we have our validation data equals dataset dot image folder because we're working out of an image folder. Root equals our valdir, our validation dir, which I don't for transparency. Right. Validation dir. And then we want to apply the same transform as the other thing. Wonderful. So now we have our two variables of data sets. And then from here, print class to index, training data set. So this class to index, IDX, I assume. I don't. Again, we'll come back to this, and then we start looking into the data loaders. So for the data loaders, you're going to take a data set, right, which we are performing these certain transforms onto. We're going to shuffle through them, and they have a certain number of workers, and we're going to set a batch size. We're going to set the batch size to like 4, right? Since we only have 10 pictures, we'll set it to 5, right? We'll set it to 5 for the batch size, or we'll set it, yeah, we'll set it to 5. And then for the batch size for here, we'll set it to like 1, I guess. We set it to 1 because we only have 3 validation pictures right now. So let's go ahead and knock this out. Training data loader, right? And then we're gonna have a validation data loader. Okay. And how do we want to interact with this? Well, we're using the data loader class. We're just gonna have certain parameters. What's the data set is first, which is gonna be training data. And then I believe it was batch, which we said is gonna be 10 or 5, right? 5. And then you have shuffle, so it's not just the same order every single time. And then num workers equals 1. Let's just say that. Right? So same concept, we'll come here with the data loader. And since we're using the validation side here, data batch equals 1 because we don't have that many files. I believe this is going to be set to false. Uh, validation, validation data. This is going to be set to false because it's just fresh pictures, right? We don't really mind it not being randomized. So this will go ahead and wrap up the rest of the training.py. So let's go over this one more time. We have our torch, which is going to give us our torch vision. And inside of that has data sets to transform. Data sets are essentially the picture and label that is being used. The label is happening inside of the directory of this training dir that we have. They have train. This train data has the labels of receiver and cornerback, which applies to all the children inside of its directory when used as the data as the parent dir. From there, we have our bumblebee, which is a transform object that is going to resize. We already went over this. And then we just knocked out the training data sets collection, which will take all the data or take all the images from this directory and perform the transform onto them so it can be used by the data loader properly, which the data loader then references these training dir pictures. Same with the validation data loader, referencing the validation data pictures, batch 1, batch 5, shuffle true, false, no markers 1, 1, yada, yada, yada. Wonderful. So amazing. uh, that's it. Yeah, honestly. I just wanted to knock this out super fast, give y'all something. I wanted to do something, and it would be heinous of me to go ahead and after everything I've preached so far, learn without you. So this is learning with Alexander, right? This is not come look at what Alexander learned. So that is that's all for today. Actually, let's squeeze 10 minutes out. Just for the fun of it. What else can we look at really quick? Fun fact about AI. I mean, it's not that fun of a fact if we already know this, right? And you know, let me just actually, let me express one thing. As I said before, I'm not gonna go and learn without you, right? The whole purpose of this is for us to learn together. And one of my favorite parts about this that I've just realized at this moment here is I can say that we already know this. And I know for a fact, if you watch my videos up until now, we do, as a collective, as a whole, already know this. So being able to speak without having to think about, did we go over this? Did I touch on this? When I know the only reason I can know this is if we learned it together, is actually really, it's really nice. It's really nice. Saw this, saw this. Yep. Chinese change and input model. Yep. I'm not sure why it would, because then you have to cut through the you have to cut through the layers a lot. You have to cut through a lot more layers with the convolution layers if you do double the image resolution. Chain hop panels, data, sun, creates points. Yep, because like we said before, the 400 versus 60, it's gonna get so used to just guessing 400 that it's so much more likely to be right just guessing what the bigger number, what the bigger supply data is, simply because it's gonna be there more often than not, right? Uh, yep, we already know that. I don't know what it means by first view at box. Uh, I see. So I guess, 10% of the data would be, oh, there's these six receiver pictures that really they're not that great, but they would have provided the AI a way to handle those edge cases if the stance was a little wrong or whatever the case may be. And then, yep, that's understandable. Cool, 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 cool. So, 10 fun facts for y'all as well. And that is all. I hope y'all have a good rest of y'all day.